Node analysis is based on the Kirchhoff current law. What is meant by Kirchhoff? So this is a node A, and this is the current, it is I1, and this is the current, it is I2, and this is the current, it is I3, and this is the another current, this is the current, it is I4. The algebraic sum of the current meeting at a point or a node is always 0, or we can define like this: the total current leaving a junction is equal to the total current entering the junction. So applying the KCL at node A, we can write like this: summation of I at node that is equal to 0. Or we can write it as sum of the current entering the node, you can take it as a -1, and leaving the node you can take it as positive. Then you can write it as I1 leaving the node, it is plus I2 plus I3 plus I4 is equal to 0. Or we can write it as minus I1 is equal to minus I2 minus I3 minus I4. Or we can write it as I1 is equal to I2 plus I3 plus I4. That means algebraic sum of the currents meeting at a node is equal to 0, or sum of the current entering the node is equal to the sum of the current leaving the node. This method will be uses the analysis of the different nodes of the network, and here one of the node will be assumed as a reference node whose potential is assumed to be 0. This is also called as a zero potential node, or we can call it as a datum node. And other nodes, the different voltages are to be measured with respect to this reference node. The reference node should be given a number 0, and then the equations are to be written for all other nodes by applying KCL. To understand the concept, I'll write down one diagram. So assume the diagram it is like this, that is network, and this is current, and here this is your one more current. This you can take it as a I1, and this you take it as a I2, and this you take it as a R1, and this is R2, and this is the R3. Here this is the datum node or a reference node. This is numbered as a node 0. You mark the node. This is the node. You mark it as a V1. This is another node. You mark the node as a V2. Now you apply the KCL at node 1. Apply KCL at node 1. At node 1. To apply the KCL at node, what are the branches it is connected? This branch it is connected. So what are the branches it is connected? So this branch is connected, this branch is connected, and this branch is connected. To consider all the 3 branches. Now what is the current flowing to this branch? What is the current flowing to this branch, and what is the current flowing to this branch? Here the current I1 is entering the node, therefore we take it as a minus I1 plus. What is the current flowing to this one? V1 minus 0 divided by R1. This is a 0 potential. V1 minus 0 divided by R1, that is equal to V1 by R1 plus V1 minus V2 divided by R2, that is equal to 0. When writing the node 1, you take this as a I potential when you compare to the V2, higher potential when you compare to V2. Therefore, you have to write it as V1 minus V2 by R2 is equal to 0. Then take the common factor V1, then you can write it as 1 by R1 plus 1 by R2 minus 1 by R2 V2 is equal to I1. Call this equation as a 1. Then apply the KCL at node 2. Apply the KCL at node V2. That means what are the branches it is connected for the node V2? So these are the branches it is connected. This branch, and this branch. Now we can write it. Now at the node V2, write a expression here now. That is V2 minus V1, V2 minus V1 by R2 plus V2 minus 0 by R3, that is V2 by R3, and then this is current entering minus I2 is equal to 0. This we can write it as minus V1 by R2 plus 1 by R2 plus 1 by R3 into V2, that is equal to I2. Call this as equation as a 2. Now we can solve the equations 1 and 2 and find out what is a V1 and V2. We have to find out what is a V1 and V2. You consider one branch like this. Okay, this you labeled as a node V1, and this is the current, it is I, and this is your R, and this is the Vx, and this is the reference node. Then what is the current here? The flowing I1. You can write I1 is equal to V1 minus Vx divided by R. We are assuming that V1 has a higher potential when compared to Vx. Therefore, the current flowing in this branch I1 is equal to V1 minus Vx by R. Suppose if the current is Vx is higher potential when compared to the V1, then we can write it as Vx minus V1 by R. Suppose if it is in negative positive, this is negative positive, then you can write I1 is equal to V1 plus Vx by R. Next, you have to discuss super node. So what is a super node? To understand the super node, you have to write a diagram like this. So this is the circuit. This is here, I'll consider a positive, negative, and this is the node, and this is the, and here it contains the diagram like this, and here it is like this, and here the resistance it is like this. This is the resistance, it is R1, and this is the resistance is R2, and this is the resistance is R3, and this is the resistance is R4. Okay, this is the label this as a node, as this is a V1, and this node is a V2, and this node as a V3, and this we taken as a reference node or a datum node. So in this case here, the node, the voltage, this is the Vx existing between the two nodes, that is V2 and V3. Therefore, this will be acts as a super node. This is your super node. This is the super node. So how to write a equation now? Now apply the KCL at node 1. Apply KCL at node V1. When apply the KCL at node V1, you can write it as, so assume that this current at is as 2 amps. Okay, then this is the current. What are the branches it is connected? This branch, this branch, this branch. Therefore, you can write it as like this. Current is entering, therefore it is minus 2 plus V1 minus V2 divided by R2. Okay, plus V1 minus V3 divided by R1 is equal to 0. So Next it is take the v1 as a common factor, then it can write it as a 1 by r1 plus 1 by r2 minus 1 by r2 v2 minus 1 by r1 v3 is equal to 2. Call this equation as a 1. Then you write a one constraint equation, then you can write it as, so vx is equal to, which is a positive sign, v2 is a positive sign, that you have to write first. Vx is equal to v2 minus v3, that is equal to second equation. Now solve the equations 1, 2 and 3 to find out what is a v1, what is a v2 and then what is a v3. This is the super node concept. Then we'll solve the problem under node analysis. So assume that the network is like this. This is the one diagram. So this is the diagram like this. We assume that it is a diagram like this. And this is your 15 volt, and this is the 1 ohm, and this is also 1 ohm, and this is your zero point 0.5 ohm, and this is 2 ohm, and this is 1 ohm, and this is the 20 volt. So in the exam they can ask the question like this: find the current to each resistor of the circuit shown in figure by using nodal analysis. So I will mark the current like this. This is the current I am marking this as a I1, and this is your I2, and this is your I3, and this is your I4, and this is your I5. That means you have to find out what is the I1, I2, I3, I4 and I4. First you have to mark the node. This is the node 1 V1, and this is the node V2. Now apply KCL at node 1. Apply the KCL at node V1. Apply KCL at node V1. So what are the branches it is connected to? This branch and this branch and this branch. So we can write an equation like this: V1 minus 15 by 1 plus V1 by 1 plus V1 minus V2 divided by 0.5 is equal to 0. Simplify this. You can write it as a V1 minus 15 plus V1 minus 2V1 minus 2V2 is equal to 0. This is a plus sign here because it is a plus is there. Then V1 plus V1 plus 2V1, that becomes here 4V1 minus 2V2 is equal to 15. Call this equation as a 1. Similarly, you apply the KCL at node 2. Apply KCL at node V2. That means this V2. What are the branches that is connected? This branch, and this. Write expression now here. V2 minus V1. V2 minus V1 divided by 0.5 plus V2 by 2 plus V2 minus 20 divided by 1, that is equal to 0. Further you simplify this, we can write it as 2v2 minus 2v1 plus 0.5 v2 plus v2 minus 20 is equal to 0. This is minus 2v1 plus 3.5 v2 minus 20 is equal to 0. If you further, you can simplify this is minus 2v1 plus 3.5 v2 is equal to 20. Call this equation as a 2. Now you can solve the equations 1 and 2. Find out what is a v1 value and v2 value. So that is, after solving, we'll get a v1 is equal to 9.25 volt and v2 will be 11 volt. Then you can find out what is the current I1, I2, I3, I4 and then I5. So I1 is given by I1 is equal to V1 minus 15 divided by resistor value is 1. So this is 9.25 minus 15, that gives you minus 5.75 amps. So I1 is flowing, whatever assume no, in that direction it will not flow, the current will be flowing in the opposite direction. Then this is I2 is equal to V1 by 1, that is equal to 9.25 amps. And I3 is given by V1 minus V2 divided by 0.5. This is 9.25 minus 11 divided by 0.5. This is minus 3.5. Here also I3 is flowing in a opposite direction. Then it is one more. I4 is equal to V2 by 2, that is equal to 0.5 amps. And then this is I5 is equal to V2 minus 20 divided by 1, that is your minus 9 amps. I5 is also flowing in opposite direction.